Okay, as I said, I'll make sure it's done within an hour, so you have time to walk, relax, have your dinner before your term test. All the best, good luck, okay? I'm pretty sure it's easier than the multiple choice in 303. Right, so let's look at planetary gears. Okay, again, the formula we're going to apply is based on rigid body general motion. General motion means there's linear and there's rotational. Okay, so the formula that we're going to apply is still the same. VA is equal to VB cross omega, not cross, seriously, plus by omega AB cross R A from point B. Okay. So formula is still the same. The only thing that's different is we're dealing with planetary gears now. Okay, planetary gears. All these examples can be found on yesterday's lecture notes. Okay, so I'm going to copy the question. We're going to work based on the question. Okay, and I have 3 questions to do. The textbook maybe have 5. So if there's a homework question on planetary gears, you'll be straightforward. Or you can answer it. Okay, the only department that's going to calculate planetary gears is us. No one will handle it. Mechanical will have to do it. You can't tell the chemical engineer to do the gears. You cannot tell the material science. Civil engineers don't do gears. What do? Anything that don't move. Okay, we deal with the stuff that move. Okay, stuff that move is us. Right, so I like to explain the term planetary gears. So what you are seeing is a planetary gears. But before we go into planetary gears, let's look at our solar system. I'm not being funny down here, but let's look at our solar system, okay? In our solar system, we have the what? Oh, this is a real ugly sun. We have the sun. Right? So this is the sun. And the sun is usually associated to the center of rotation. Yes or no? Right? So where we are on planet Earth, the sun don't seem to be moving. Okay. So what is moving round, going round, is what we call our planet. The planet is going round this way and is also rotating about its own axis. Yes or no? Right? And there is another thing that you have to consider in planetary gears. This one over here is not superb. Okay, I'll try to make it better. All right. This is what we call the orbit. In the gear sense, is known as the ring. Okay. So what you see over here, coming back to here, question for you, which one is the sun? Anyone? Yeah, don't point at the sky, okay? Which gear is the sun? E, okay? So the sun is our gear E. Well done. Which one is our planet? Which gear? Gear C and gear E. Are we clear? Gear C and gear E are fused together. Okay, gear C, sorry, C, not E, C and B. Okay, B and C, gear B and gear C. And which is the ring? The ring is our what? Gear R. Okay. So don't panic. Okay. You have a ED. ED is just an arm. Okay. So that is nothing to do with planet. It's just an arm that's over there. Okay. So always remember, in the planetary gear system, one of the gear has to be not moving. We have 3 gear sets. Yes or no? We have the ring gear, we have the planetary gear, we have the sun gear. In any of this system, one gear is not rotating. It can be either the ring gear is not rotating, or it can be the sun gear that's not rotating. Okay. I don't see when can the planet gear not rotate. I can't see that at all. But anyway, so let's come back to the problem. The elliptic cycle gear train consists of the sun gear. So when you hear like, sun gear, okay, means everything is rotating about this axis. Yes or no? That's the sun gear. So, which is meshed with the planet gear B. Okay, so this is planet gear B, as you can see. And in mesh with a ring gear R. So this is our ring gear R. Okay. If the correct connecting rod DE pin to B and C is rotating at omega DE is equal to 18 radians per second. So this is our point D. And this is our point E. So we are talking about, so over here, this is what we term our what? Our connecting link. Okay, it's rotating at 18 radians per second about the pin at E. Determine the angular velocities of the planet and the sun gear. Okay, so let's see what we need to find. Okay, so we need to determine our omega A and our omega B. Okay, omega B. And note that omega B is also equal to omega C. Okay, so that's what we know. Okay. So now I'm going to start working on here now. Okay. I'll let you guys finish copying first. Are we okay? Then we come over here. Let's focus on this. I'm going to zoom it in. Undo. How come we get oblique? Okay. Okay. Let's focus on this system over here. Okay. So the first thing we know that the ring is fixed. Okay, i.e. omega R is equal to what? Is equal to 0. Okay, so we have to determine, we have to find, right, omega A and omega C, and we know that omega C is also equal to omega B, right? So given to us, we know that omega DE, okay, we know that omega DE is equal to 18 So positive 18 K radians per second. Positive is because it's going anti-clockwise. Okay. So now we are going to focus on the planet. Okay, we're going to focus on the planet. So I'm going to sketch the planet out. So we're going to focus on the planet here. I don't like to force you to focus on the planet here. Well, I'll draw the velocity diagram. Then you can see the reason why. Are we clear? Okay, I don't want to stand down here, start explaining, and you say, whatever. Okay, I want to show you what happens when we focus just on the planet gear. So if I were to draw our planet gear, okay, I'll try to draw it to size or not. You say, Eugene, what are we drawing here? Okay, so this is our planet gear. Okay, so this is our label this. This is our gear B. And there's one in the center which is smaller. Over here. This is our gear C. Okay. So we are given, we know that at this center over here, right, is point D. And point D, we can relate this to our what? We can relate this to our velocity vector now. And this is equal to our VD. Now, we are finding velocity at that instant. Okay? At that instant. Okay. So what I've done is we are going to focus on these gears over here. Okay. I'm going to call another point. Okay. So this point over here, that I'm going to call over here, right? This is on gear C, and this is our VC. Okay, VC. So VC in this case is equal to what? 0. When I call VC is at this point over here down here. So this is my point C. Okay. Why? Yeah. Yes. No, VC is equal to 0 because VR is 0. Okay. Whenever you have two, I don't know, have you been taught this yet? Whenever you have two gears that are meshing, at the point of mesh, velocity has to be the what? Okay, are we clear? When two gears are meshing, right, in contact, at that instant, the velocity has to be what? The same. Yes. Yes. The velocity is equal to 0 because the ring gear is equal to what? 0. It's pretty abstract, am I right? I can give you an example. volunteer. I'm volunteering. Can you stand out here?